Hi everybody, I am Dr. T. Miranda Lakshmi, working as an assistant professor in the Department of Computer Science, St. Joseph College, Cuddalore. Today we are going to see an important topic in the operating system, that is memory management. So before getting into memory management, normally this operating system is being categorized into three functions. One is information management, the other one is the process management, and the third one is the memory management. So these are the three works carried out by the operating system. So if you're going to take information management, it will be managing all the information which is used to create a file or create a directory, or if you want to change a directory, all these will be taking place in your system through this information management. If you're going to take a process management, it will be scheduling the process. Now in this topic, memory management, we are going to deal about Hi everybody, I am Dr. T. Miranda Lakshmi, working as an assistant professor in the Department of Computer Science, St. Joseph College, Cuddalore. Today we are going to deal an important topic in the operating system, that is memory management. So before getting into memory management, you have to have a glimpse about what are the functions of the operating system. So we have already discussed about what are the functions. The main three functions of operating system is the information management, process management, and the memory management. So the information management, as you know, that it is used for creating a file, creating a directory, if you want to change a directory. So all these, if you want to read a file, if you want to close any file, all these things will be carrying out by the information management. Next, if you're going to go for your process management, the work of your process management is to schedule the process. The next one is your memory management. So if you're going to take memory management, it is mainly concentrated on allocation and deallocation of memory chunks. What is meant by allocation and what is meant by deallocation? What type of memory here they are talking? Here they are explaining about the random access memory, or you can say it as primary memory, or you can say it as a main memory. The main memory, how it is being allocated and how it is being deallocated. What is meant by allocated? So if you're going to take a process from your hard disk and if you're going to place it inside your main memory, it is called as allocation. So after the processor has completed its work, again we have to remove that process from the main memory. That is called as deallocation. So this is the main work of the memory management. It is used for allocation and deallocation of memory chunks. Next one is, what are the importance of memory management? First thing is data security. We are going to safeguard all the sensitive data. Next one is resource utilization. If you're going to take your resource utilization, we are going to go for how we are going to allocate the resource, how we are going to deallocate the resource, how compaction is going to be taking place, how swapping will be taking place. All these things we'll be discussing in further classes. Next, stability. So stability, when you're going to go for memory contribution, reliability of information must not have crashes or must not get any errors due to this memory management. So these are the three important factors of memory management. The next one, if you're going to take your memory management, there are two techniques. One is the real memory management. You can say it as the real memory management. The other one is your virtual memory management. What is the difference between real memory management and virtual memory management? So let us consider, if you're going to have a 50 set of program, okay, a 50 set of that is lines of code. If this 50 set of lines of code must be present inside your main memory, then only your CPU will be start executing. That is called as real memory management. If you're going to go in for your virtual memory management, if you're going to have 50 lines of code, it is not necessary that all the 50 lines of code must be present inside your main memory. It is enough to have some, for example, if it is going to execute some 3rd line and 10th line and 18th line, only these lines need to be present inside your main memory. This is the main difference between your real memory management and virtual memory management. So real memory management, in this method, it needs a whole process to be inside the main memory. The whole process, I told no, we have to have, if you're going to have a set of code, all this full set of code must be present inside your main memory. But if you're going to go in for your virtual memory management, it is enough to store a part of a process inside the main memory for your execution. Next one, if you're going to take your real memory management, it is being broadly classified into contiguous real memory management and non-contiguous real memory management. What is meant by contiguous real memory management? What is the meaning of contiguous? So when you're going to allocate the memory, I told no allocation. We are going to bring the process from your hard disk and you're going to place it inside your main memory. So when you're going to allocate inside your main memory, what is meant by contiguous means it has to be stored continuously. The memory space must be present continuously and the process should be placed inside the memory continuously. If it is not going to have continuous spaces, it will not be allocating the process. For example, if I am going to arrange the students in the benches, I have to allocate continuously. Number 1, number 2, number 3, number 4. I will not be able to sit number 1. Then I cannot leave a space and I can go for number 3, number 4. I cannot do it like this. In the contiguous real memory management. In contiguous real memory management, the memory allocation must be in a continuous manner. Then only we can allocate the process. Next one is non-contiguous real memory management. So it is vice versa. It is an opposite of contiguous memory management. Contiguous, we have to need continuous spaces. But in non-contiguous, it is not necessary to have continuous spaces. We can have, so one process can be, that is, for a process can be allocated in one position, in the other position. Wherever there is free spaces, it can be allocated. That is called as non-contiguous real memory management. So when you're going to take your contiguous real memory management, so it has been arranged. It has been arranged in a continuous manner. So under this category, we are having 3 methods. One is single contiguous real memory management. The second one is fixed partition memory management. And the third one is variable partition memory management. So single contiguous means your main memory will be divided into 2 parts. One is the OS part, the other one is the user part. Only one partition you will be having for your user part. A single program will be loaded and it will be coming out. That is your single contiguous memory management. When you are going to go for your fixed partition, when your system generation itself, they will be partitioning. Partitioning is nothing but you are going to divide your main memory into some blocks. That is called as partitioning. This partition is of fixed size. So these things we will be discussing in detail in further classes. Variable partition. So here variable partition is nothing. What is the difference between fixed and variable partition? There the partition will be fixed. But here the variable partition, whenever a process comes, it will be partitioning it and it will be allocating it. So that is the difference between fixed and variable partition. It will be changing. In variable partition, the partition size will be going on changing. The next one is non-contiguous real memory management. The non-contiguous real memory management is implemented in 3 ways. One is paging, second one is segmentation, and the third one is combined system. So if you're going to take paging, it will be similar to your fixed partition. And if you're going to take segmentation, it will be similar to your variable partition. Combined system, a combination of paging and segmentation is called as your combined system. So common issues and solutions of memory management. One is fragmentation. This is a very important thing is fragmentation. What is by fragmentation? That is when you're going to allocate any process, the wastage of memory is called as fragmentation. So those fragmentation issues has to be properly handled. Then memory leaks. So there must not be any memory leaks. Then the other thing is concurrency. So there must be concurrency issues must be tackled in a safer manner. Thank you.